Hello friends, in this particular video I'm going to generate a curve, and for that I'm going to use Matplotlib. So the question is, how do I generate the curve? Well, to generate a point we need x and y. So how is this going to frame? And it will be done dynamically. So for that reason I have given a call to NumPy linear space function. It takes three arguments. The first is the starting value, second is the ending value, and how many numbers do you want. So I said the first starting number would be -5 and it would end +5. In between that you have to generate 10 numbers, and after you have done that you create a double dimensional NumPy array. So would you like to see what are the numbers that have got generated? Okay, great. Let me print them. I comment this portion. Let's come over here and let's run the code. Python basic.py. I hit the enter, and what you can see is 10 numbers, and they are all evenly spaced, starting from -5 to the +5. So 1 2 3 4 5 6 7 8 9 10. So this is my NumPy array where it has generated from -5 to 5. All 10 numbers are over here. So I got the x coordinate, but what about my y? So I need to print, or I need to generate y as well, right? So how do I populate y? And for that reason I am using the quadratic equation x square. So if you look over here, what I have done is, since it's a vector, since this particular array is a vector, so I will pass this particular function to each of this x. At the 0th index it will be -5, so -5 square. At the 1 index it will be -3 point something square. At the index number 2 it will be -2 point something square. In this way it will go up to the 9th index, that is 5 square. Remember, it will start from 0, then 1, then 2, then 3. In this way it will go up to n-1. So would you like to see what is the y on basis of this quadratic equation? Okay, great. So let me show you that even, and here it comes. You will be seeing both x and y, and the relationship is square, x square. So -5 square, -3 followed by 888 square, -2.77 square is this. In this way it will go up to 5 square, which is 25. Hence we have got both x and y coordinates. Keep it in mind, since it's a NP type matrix, so for that reason it is actually in the form of vector, so you don't need to run loop for doing this. I mean, to give the call to the quadratic function for each of this index. You need not have to do that, because it's not a regular Python list, it is a NumPy array. So NumPy array has this particular functionality, being its vector, so it will it doesn't require this looping part. It will be done in one go. Hence we already have these x and y coordinate, and now what we are going to see is that what are the intermediate points if I want to show them together. So let me show you this, the intermediate points, and for that reason what I need, I am running the range function, because I have got this array over here, that is a NumPy array. So I have to count how many indexes are over here. As we know, the length starts from 1, so it will tell you there are total 10 indexes are there, and I will print them together. So let me show you what I mean by this is that, as you can see over here, look, these are my coordinates. So I have my first coordinate. This is the following coordinate: -5 followed by 25. The second coordinate is -3.88 followed by 15.12. So this is my second coordinate, third coordinate, fourth coordinate. In that way I have generated these coordinates, and they are all now together. So independently I generated x, independently I generated y. By now I have combined together in the form of a coordinate. So now it can be easily put forward into our graph, and it will generate a curve. So for that reason we have to use Matplotlib. So let me uncomment this line, and I have given a call to matplotlib.pyplot as plt, and it comes up with a very nice function called plot, and plot needs both the coordinate x and y, and wherever this coordinate mix together we will be labeling it with a particular marker. So let's run the code one more time to see how exactly the graph is getting created, or to better to say a curve is getting created, and let's see the curve now very minutely. Please watch it. The very first coordinate is -5, that is x, and y is 25. So look at the x. So x is -5, so over here somewhere over is -5, and the y coordinate is 25. Exactly the point comes on the top of this particular green line, so it would be -5 somewhere over here with that of 25. That is the first coordinate. Then -3, so it's close somewhere over here, just slightly before 4, somewhere over here with that of 15.12 is the coordinate. Then come -2.78 is just over here. 2.78 is over here, 2.78 is over here. So, and 2.78 followed by 7.72 is somewhere over here, 7.72 is over here. That's what got generated. Then comes -1.67, the 1.67 just before 2. So this is the place where 1.67 is there, and 1.67 is with 2.78, so it's close to 2.78 over here. So that means one thing is very clear, that these are the negative value of x, and then at the like after 0 it is slowly becoming positive value. As you can see over here, the last negative value was 0.56, so it's close over here. 0.56 has got 0.31, so 0.31 is over here, right? And thereafter it is having the again the positive value. Now 0.56, see, all the negative value what we have got over here is now getting transferred into a positive value over here. So 0.56 positive value 0.56, minus 1.67 is now 1.67, minus 2.78 is now 2.78, and that's the beauty of this linear space. So linear space array it has generated. That's the reason why once we have a negative value of x and the same positive value of x, and since we have gone for the quadratic equation x square, hence we are getting a curve, and this curve actually looks very similar to that of a parabola, right? But yes, there is a sharp edge out there because I have just generated 10 points. That's the reason why you can say that these are just the point which have been connected by a line. Hence the exact smooth curve is not coming. And to generate the smooth curve, what I have to do? I can increase my data points. So instead of just going for 10, if I go for 30, of course my smoothness of the curve will increase, and I have to clear this terminal because now we are going to see 30 different data points. So of course the curve is much smoother compared to what it was before, right? So over here now we have got 30 different data points, and it has been linearly plotted. So now we can see a very smooth curve that we can come across. Let's see whether 20 data point could have generated how well the curve would have been. So instead of 30, now we go with 20, and that won't be bad at all, I believe. See, it's not a bad at all. So it started from -5 to go, it went to 5. So -5 was somewhere over here with that of 25, because the y value is generated by the quadratic equation x square, and that's how we are getting this particular shape. So wherever the x and y coordinate mix, there where I'm plotting the dot, and the x label is x and this is a y label, and the grid I have given so that you can see it properly. And finally we have to display our matplotlib graph, and for that reason we have got plt.show. I believe this particular example help you to understand that how exactly linear space of NumPy array is going to help you to generate coordinates in context to x, as well as you have to involve some function over here in order to generate y, and that's how you connect both x and y coordinate together, which will generate a graph. So currently we saw a parabola graph. In the upcoming video we will be exploring more about this based on how exactly you generate your data points. I believe from this particular video you get an overview that how exactly the coordinate functions that can be used for generating the coordinates, and eventually we will get some curve in the graph. Okay, so that's all from this video presentation. See you soon. Bye bye.